Hello and welcome to Ginger Engineering. In this video, I'll be showing you how gearing and compound gearing works. Alright, so to start with, here I've got an example of regular gearing. I have a smaller 12-tooth gear as the drive gear, and I have a larger 84-tooth gear as the driven gear. Now, the reason to use gearing, obviously, is to make something either move faster or move, well, stronger. So, the way this works is to find a gear ratio and to understand if it's going to be stronger or faster, you take the driven gear and you divide it by the drive gear. So you take the number of teeth, which is 84, and divide it by 12. So we get 84 divided by 12 is 7. So this is a 7-to-1 drive, which means for every 7 turns of the drive gear, you get 1 turn of the larger gear. So this specific gearing means the output is going to be a lot stronger and slower. So here I'll show you what this looks like. Alright, so the driven gear is moving a lot slower, but it has a lot more power to it. Now if we switch this around, the gearing, to find the gear ratio is the same way. You do the driven divided by the drive. So in this one, it's 1-to-7, or it's 1/7, while the other one was just 7, because this is 12 divided by 84. So then when we get this one turning, this gear is turning much quicker, but it does lose a lot of power. Now, another way we can do gearing is we can take, and this can still be the driven gear, but if we want the direction of the driven gear to change, so let's say it's going one way, but we want to turn the other way, we would use idle gears. An idle gear does not change the amount of power the output gear receives. All it does is simply change the direction, or it extends the power, or extends the force across a longer distance. So if this were connected to this gear, and it were connected to our driven gear, for example, then the direction of the output gear in this specific example, it would just change the direction. And you can have any amount of idle gears in between the drive and the driven gear, and it does not change anything other than direction, and extends the force across the distance. And that's regular gearing. Now let's say you want to have a much, let's say, quicker drivetrain, and you can't get quick enough out of simply the largest 84-tooth gear to the smallest 12-tooth gear. So what you would want then is compound gearing. Compound gearing is a way to get really small or really large gear ratios. And the way it works is you would have I'm going to show you with sprocket and chain. And sprocket and chain works the same way as gears. You just divide the number of teeth of the driven by the drive to get the gear ratio. This example for the compound gearing, let me just take this off. So if we wanted it to be much quicker like that, then we'd once again have the largest gear as the drive gear. So this is just an example, but what it would be is you would have your large gear, and your large gear would be turning the smaller gear. I'm not going to actually connect it with the chain, but if this were turning this, it would be just like if these two were turning. This would be moving very quickly. This would be moving slowly, well, at regular pace, but the end force would be much quicker. So that's just a regular gearing. Now, to make it compound, you're actually stacking gears. So you'd have these two connected, by a chain, and then on top of this middle one, you'd place a large gear again. It can be, if you want to actually change the force at the end, you'd have to make sure that it's a larger gear than what you're putting it on top of. So this is what I have here, and then you'd connect this larger gear to another smaller gear, and this would be your driven gear here at the end. And to get the gear ratio to it's still driven divided by drive, but what you would do is just you would take the two different driven divided by drives, and then you'd multiply them together. So you'd have however many teeth here divided by however many teeth here, and then you would do that again with however many teeth here divided by this many teeth, and then you'd put those two ratios together and you get your final ratio. And that's gearing and compound gearing for you. Thanks for watching.